Now we'll be discussing transformations. In the previous lessons, we learned all of the functions, the basic functions, and what their graphs and characteristics look like. That is a helpful video to know going into transformations, because now we're going to take these basic functions, like the square function that we've already learned, and we're going to start to turn it, twist it, stretch it, shift it, so that way it turns into a different graph based on things that we already know. So if you haven't already watched the previous video from section 3.4, now is a good time to do that, because it'll be beneficial to already have known what these core functions, I call them, or library of functions, will look like. So again, let's start with the core function. In this case is x squared. This is the square function. You should already know what the square function looks like. We don't have to create a table of points because we should have this memorized. The core function of a square function is a parabola. Goes through 0, 0, 1, 1, 2, 4, and is symmetric over the y-axis. So by this point, everybody should be able to draw that from memory. We're also going to look at what this will look like in a graphing calculator. In a graphing calculator, if I graph x squared, you could see the parabola is going to match exactly what I have in the graph above. Now in the following two graphs to the right, we're going to add a number or subtract a number and see what that does to my graph. Let's do it by hand first without the graphing calculator and see what the points are going to do. So let me take these 5 core points, which means x is 0, 1, and 2, -1 and -2, and let's see how they get shifted. So if I plug x is 0 into right here, x squared is 0, plus 2 is 2. So I'll have a point at 0, 2. If I plug in a 1 for x, 1 squared is 1, plus 2 is 3. If x is 2, 2 squared is 4, plus 2 is 6. If I plug in a -1, -1 squared is 1, plus 2 is 3. -2 squared is 4, plus 2 is 6. So let's plot these points and see what the graph looks like. So 0, 2, 1, 3, 2, 6, -1, 3, and -2, 6. We can also graph it with the graphing calculator. So if I go back to my y equals, I can turn that x squared, if I just add 2 to that, it's the same graph. So let me go back and actually put them both on here. So let me do two graphs. I'll do the original x squared, then I'll do the x squared plus 2. And I'll do both, and I'll draw them in order. So it'll draw the original library function, square function first, and then I'll add the 2 on the second graph. So here's the first one, x squared. Now here's the second one, which is x squared plus 2. So you can kind of see what's happening as we add the 2. So let's go ahead now and subtract 4 and see what happens. You probably can guess already what's going to happen, but let's verify it one more time. So let's put these same points in. If I plug in 0 for x, I get -4. If I plug in 1 for x, I get -3. If I plug in 2 for x, I get 0. -1 squared is 1 minus 4 is -3. And if I plug in a -2, I get 0. So plotting these points, I get 0, -4, 1, -3, 2, 0, -1, -3, and negative 2, 0. So let's see again what will happen. I put that third graph on here, which is x squared, which is x squared, and I am going to subtract 4. So it'll graph them in order. Here's the first one, here's the second one when I added 2, and here's the third one when I subtracted 4. So you can see what's happening. It's the exact same graph, but they're just moving. In other words, they're actually what's called a shift. Okay? This is called a vertical shift. So I took the graph, I either shift it up or shift it down based on the number that I'm adding or subtracting from that squared term. So the conclusion that we're going to make is that we're going to shift these up and down. So if you're adding a real positive number to this function, any number you add to any core function, if this is my core function, and I add any number to that outside of the function itself, you're going to take the whole graph of f of x and you're actually going to shift it up k units. Now if this is my original core function and I subtract that value, then that means we're going to shift it down k units. So this is a vertical, both of these represent a vertical shift. So let's look at one more to tie it together, one more example. This time I have the absolute value function, which we know is a v. So we already have this one memorized. We already know how to graph it. So now I'm not going to make a table at all. I'm just going to go right into my shift. So what I'm going to do is I'm going to take every point over here and I'm going to shift it up 1 unit. Okay, so 0, 0 is now going to be at 0, 1. 1, 1 is now going to be at 1, 2. 2, 2 is now going to be at 2, 3. So you see what's happening. Every point got shifted up 1 unit. Same thing over here. Every point will get shifted up 1 unit. So my whole graph moved up as well. What's going to happen to this graph over here when I subtract a 3 outside of the function? It's going to move it down 3 units. So the original origin, which was the vertex or the bottom of the base of the V, is going to move down 3 units. And then every point is just going to move along with it. Like that. So let's see what that looks like on the graphing calculator, because it is always nice to see technology convincing us that our answers are truthful. So if I graph all 3 graphs on one grid line, it'll give me the original core function first, which is on the left. It'll give me the middle one second. It'll give me the third one last. So let me hit graph. So here's my original absolute. Here's shifted up 1. Here's shifted down 3. So it does in fact do exactly what we intended it to do. Good. So let's move on to the next transformation, which is now called the horizontal shift. So on the first page we practiced the vertical shift, meaning things are moving up and down. A horizontal shift means items are going to be moving left and right. So let's see how we can get that to occur. Again, let's start with the first original library function, which is the square function. This is the parabola. So I'm going to put my key points in there, connect them together. So now I'm going to do a shift from that position. This is going to be x minus 3 squared. My parentheses are missing there. Okay? So I'm going to do x minus 3 squared. So let's look at what the table is going to look like. So I'm going to put in some points here. Let me put in 0, 1, 2, 3, 4, and 5. So if I put in 0 for x, 0 minus 3 is negative 3, squared is 9. So that's like way up here. If I put in 1 for x, 1 minus 3 is negative 2, squared is 4. If I put in a 2 for x, 2 minus 3 is negative 1, squared is 1. If I put in a 3 for x, 3 minus 3 is 0. If I put in a 4 for x, 4 minus 3 is 1, squared is 1. And if I put in a 5 for x, 5 minus 3 is 2, squared is 4. So you can see my parabola looks exactly like it did in the original function over here. It has just been shifted. The origin has been shifted 1, 2, 3 units to the right. So this got shifted right 3 units. Let's see what's going to happen over here. Let's put in 0, 1, negative 1, negative 2, negative 3. So if I put in a 0 for x, I get 2 squared, which is 4. If I put in a 1 for x, I get 3 squared, which is 9. So that's going to be pretty tall. If I put in a negative 1, I get 1 squared, which is 1. Negative 2 for x gives me 0. Negative 3 for x is going to give me 1. So let's see, that should be enough to make my picture. Let's do one more. Let's do negative 4 for x. That's going to give me 4. Okay, so that completes my picture. I've got enough to know what's happening here. So when I graph my parabola, you can see that this graph, which should have been starting at the bottom vertex, which would be the origin, has now been shifted to the left 2 units. So let's look at some of the conclusions that we can make from what we've just figured out. So the graph of the function of x minus h, so when we subtract a number, inside, we're actually moving it to the right 3 units. So that is backwards from what most people would think would happen. Subtracting a value inside the function before you square it actually means you're moving it to the right. So a positive, or adding a number inside the function, means you're moving it left. So down here in our little theorem that we're creating, the graph says when you subtract a number on the inside of a function, you're actually moving it to the right. So adding a number, maybe h or any number for that example, means you're moving it to the left. So it does go backwards. These are horizontal shifts. So let's look at what these would look like using technology. I've put the 3 functions into my graphing calculator. The original x squared function on the left. Then we're going to subtract 3 inside the function, meaning before you square it. And then the third one will be adding 2 inside the function. So they will graph in order. Here's the original x squared. Here's the minus 3, which means it moves to the right. And then here's the plus 2, which moves it to the left. So let's try one on our own. We're going to graph this just using what we know from memory to this point. We're going to graph the function, which is the cubed root function. So if you recall back from 3.4 or the video before this, the graph actually looks like this, which is the cubed function. Then we're going to subtract 2 inside the root, so that's inside the function. Remember, if I recall, subtracting a number inside the function actually moves it to the right. So if I subtract a 2, I'm going to move this graph to the right 2 units. So that means the origin 0, 0 is now going to move to the right 2 units. This point 1, 1 will move to the right 2 units. This point at -1, -1 will move to the right 2 units. So my graph now will look like this. Over here, adding 3 inside the function means we're going to move it left 3 units. So again, 0, 0 is going to move to the left 3 units. So my graph will look like this. So again, just showing how this works with technology. I'd like to show what these 3 graphs will look like in technology. Again, always check with your instructor whether they allow graphing calculators in the classroom for exams. I personally feel that shouldn't be allowed, only because it's an unfair advantage to those that do have them, unless everybody is able to have one. But it is fun if you already do have one to kind of check your answers and see how the transformations work when you run through the different options. If you don't have a graphing calculator, you can always use Desmos, which I'll write down here. Desmos.com also has a graphing calculator on the internet. So if I graph these, you can see here is the first function right here. Then we're going to pick that up and now we're going to move it to the right 2 units. There it is. Now we're going to move it to the left 3 units. So they get kind of muddled on the ends there because they're all kind of, looks like they're kind of converging to each other, but it gives you the idea of what's happening. So let's try one more example using vertical and horizontal shifts, and let's combine them together into one big transformation. So here we're going to start by plotting the absolute value function. By now, again, we probably should have these memorized, which is the absolute value function, which looks like a V, and going through the origin. Then I'm going to do, there are 2 transformations that are both taking place here. There is a transformation on the outside of the function and another one on the inside. When anything happens outside of the function, the +1, that is a vertical transformation. This +1 is going to be a vertical shift. And since it's plus, that means it's going to go up 1 unit. This -2 is happening inside the function. Anything inside the function is a horizontal transformation. So this will be a horizontal shift. Since it is negative, it's actually opposite, so that means it's going to move to the right 2 units. So we're going to take everything that we see over here, basically the origin, that's what's going to get shifted. So the origin is going to get shifted up 1 unit and right 2 units. So now my vertex of this absolute value function is now going to be located here, and then I can just draw the rest of the absolute value function because it has slopes of 1 and -1 on both sides. What's happening over here? This again will be a vertical shift. Since it's -4, that means it will move down 4 units. Adding 3 on the inside of a function is a horizontal shift. Since it is positive, that will actually move it left 3 units. So my vertex that used to be at the origin is now going to be located down 4 units and left 3 units. So here is my new vertex. Then I draw my V from there.